Learning objectives. By the end of this section, you should be able to find the gradient of a vector, determine if two vectors are parallel, determine if two vectors are perpendicular. Parallel vectors. Which pair of line sections are parallel? A and C. Mathematically, what makes lines parallel? Lines with the same gradient are parallel. Gradient equals rise over run. Gradient of A, rise of 3, a run of 6, 3 over 6 simplifies down to 1 over 2. The gradient of C, rise of 2, run of 4, so 2 over 4 simplifies down to 1 over 2. Both have the same gradient. The lines have the same gradient, therefore they must be parallel. We can apply this to vectors to determine if they are parallel. Represent vector A and vector B as column vectors and find their gradients. A is 6, 3. The gradient of A is 3 over 6. Remember, in a vector, the top number is the x movement and the bottom number is the y movement. So for rise over run, you turn the vector upside down, and that gives the gradient of 1 over 2. Vector B, minus 8 minus 4. The gradient of B is 4 over 8. Gradient is measured from left to right, not necessarily the direction of the vector. So although our vector was minus 8 minus 4, the rise is 4, the run is 8. So that gives us a gradient of 1 over 2. The vectors have the same gradient, therefore they are parallel. Find the gradients of the vectors and match the parallel pairs. So either work off the screen or copy them down, work out the gradients of all the vectors, and then say which ones are parallel. Pause the video now and work through that. Right, here we go. A and F have a gradient 1 over 3. B and G have a gradient minus 1 over 2. C and E have a gradient of 1 over 2. D and H have gradients of minus 1. V equals 2, 7, and vector U is 4.8, 16.8. Determine if the vectors are parallel. To answer this, we need to find the gradient of the vectors. So the gradient of vector B is 7, 2. Again, remember the numbers from the column vector have been inverted because we're after the gradient. This one. This is in its simplest form. Gradient of U, 16.8 over 4.8. To get this in their simplest form, either times by 10 to get rid of the decimal and then cancel down, or do the division, 16.8 divided by 4.8. So 16.8 divided by 4.8 equals 7/2. So the gradients are the same. V and U have the same gradient, therefore they're parallel. So find the gradients of the vectors, then match the parallel pairs. You are allowed to use a calculator for this. Quickly work through that. So pause the video, work through it. Once you've done it, come back and we'll check. Right, so A and F have a gradient of 2. B and G have gradients of -7/4. C and I have gradients of 4/3. D and J gradients -3/4. E and K both have gradients of -2. And H and I have gradients of 4/7. Vector A is 3, 1. A 6, 2. 3A 9, 3. -4A is -12, -4. All of the vectors sit on top of each other. Therefore, they must be parallel. This is not affected by the direction. Even the -4A was still parallel to the other ones. Scalar vectors are parallel. The red vectors are scalars to green vectors. Match them up and state the scalar. The first one has been done for you there. So vector A is 4, 6. 1.5A is 6, 9. So work through them, see if you can match them up. Once you've done that, come back and play the video and check your answers. Okay, here we go. 16 minus 20 is 2B. -6 minus 8 is -C. -1, 2 is 0.5D. 2, 3 is -0.5A. -2B is -16, 20. 12, 16 is 2C. -3, 6 is 1.5D. -2D is 4 minus 8. 20 minus 25 is 2.5B. 12, 18 is 3A. And finally, 24, 32 is 4C. If you got any of them wrong, go back through them. It's important that we can do this. If we skip anything in the vectors, we'll be totally lost when we get to the end. It's important you can do everything at every stage. So if you have any problems, go back and do that again. We can determine if vectors are parallel by recognizing one to be a scalar or the other, or by working out the gradients of the two vectors. The method you choose will be determined by the numbers. Sometimes you can just see that one is a scalar or the other. Other times you have to work out the gradients of it and find out that way. For each green vector, there is a red vector parallel to it. Either by finding the scalar or the gradient, match the pairs of parallel vectors. So this is a calculator exercise. Work through this. Some of them are tricky. Work through them as best you can. Once you've done them, come back and check your answers. So here we go for the answers. So the red ones have been matched up with the green ones that they correspond with. So there they are, all in pairs of parallel vectors. So whichever way you worked it out, whether you recognise them as being scalars or you worked out the gradient, hopefully you got all them right. Again, if you didn't get these right, go back through them until you can understand them. Perpendicular vectors. Represent S and T as column vectors and find their gradients. So I'll quickly do that. Hopefully this is what you should have. For S, we've got -8, -6, which is a gradient of 6/8, which simplifies down to 3/4. Vector T is -6, 8. The gradient of T, -8, 6, and that will simplify down to -4/3. The gradients of vectors are negative reciprocals, therefore they are perpendicular. We should remember this from when we were working with straight lines. Perpendicular lines, the gradients are negative reciprocals. The same works with the vectors. So perpendicular vectors, for each green vector there is a red vector which is perpendicular to it. Determine which vectors are perpendicular by finding their gradients. So work through that, and once you've done it, come back and check your answers. Right, so see them matched up now. So hopefully you got them. Again, if you didn't get them, go back through them. It is important that we understand this. Vectors are notoriously hard, but it's all you've got to stick with. So if you've struggled with any of the questions in this video, work through it again. You must be competent and confident with the content of this video before you move on to the next one. So as I've said, vectors are notoriously tricky. You've just got to stick with them and work through them. You will eventually get there. Hopefully this has been of use to you. Like I said, if you struggle with it, go back over it until you've mastered it.